An electric field of magnitude 3.50 kilo Newton per coulomb is applied along the x-axis. Calculate the electric flux through a rectangular plane 0.350 meter wide and 0.700 meter long if the plane is parallel to the YZ plane. So that is the first case. So let us write what is given there. So given values are electric field electric field magnitude along the direction. It's 3.50 times 10 power 5 kilo means 10 power 3 Newton per coulomb. And rectangular plane dimensions they are given 0.350 meter times 0.700 meter. Now we have to take the first case if the plane is parallel to YZ plane. Suppose if I draw a plane, so this is a plane, and if I mention the directions along, and this is, let me take along Y, and this let me take along Z. Now to take along x-axis, suppose if I draw along x-axis, so this is x-axis. Now if I highlight this plane, so for a moment, so this is the XYZ plane. Now we need to, they were telling that in the first case if the plane is parallel to XZ plane, so this is the XZ plane. Now if I draw a unit vector along in this plane, so this is the area vector of YZ plane, area vector. Of YZ plane. Now we need to figure it out what is the flux. Flux phi suffix E equal to E bar dot A bar for the case 1. Now which you can write EA times cos theta. Now electric field magnitude 3.50 times 10 power 3 Newton per coulomb, and area dimensions 0.350 meter times 0.744 meter, and cos theta. So here the electric field and area, they both are parallel, so the value becomes cos 0 degree. Now we can substitute this value, cos 0 value goes to 1, we can multiply and everything, so then we can find it out the value. So by using, if we can do 3.50 times 0.350 times 0.700 equal to 0.8575. So if we can write that flux pi E equal to 0.8575 times 10 power 3 Newton meter square per coulomb square, cos 0 value 1. So finally you can write the answer. Flux pi E equal to, if you can multiply with 10 power 3, it will becomes 857.5 Newton meter square per coulomb square if that YZ plane is parallel to x-axis. Now for the second case, If you can see the second case, but the B1, if the plane is parallel to xy plane, if the plane is parallel to xy plane, so that is the second case. So for that, you can make the figure, then it's easy to do it. Plane is parallel to xy plane. So if I draw the plane first, so this is, if I take as x and y plane, I can mention this is my x-axis and this is my y-axis. And if I take z-axis, the z-axis is along in this direction. So this is z-axis. Now this is our plane. Now the plane area vector, the area vector of plane is along in this direction, area. And don't forget that, given that electric field direction is along x-axis, if you can take electric field along x-axis, so this is the electric field direction. Electric field direction. Now if you can see, the electric field direction and area of the plane xy plane, so they are making an angle 90 degree. Now we can write flux by E in the second case equal to EA cos theta. So here E times A cos 90 degree. So cos 90 degrees value becomes as 0 times EA, which equal to 0. So the flux in this case will equal to 0 degree. Sorry, 0. The value is 0. Now for the third case, if the plane contains the y-axis and its normal makes an angle 40 degrees with x-axis. Plane is containing y-axis and normal is making an angle 40 degrees. So in this case, for the case 3, theta they are mentioning as 40 degrees. Now find the flux value. Flux pi equal to E dot A, which equal to EA cos theta. So electric field value 3.5 times 10 power 3 Newton per Coulomb, and area, so we can get that area 0.350 times 0.350 meter times 0.700 meter times cos 40 degree. So if you can do the calculation, you can take so 3.5 times 0.350 times 0.700, which equal to 0.8575 times 10 power 3, but I need the value of cos, so I can go for my scientific calculator and I can figure it out what is the value of 40 cos. So I can get 0.7660 times 0.7660. If you can multiply that to 0.7660 times 0.8575, which gives to me the value 0.6568. So I will write that value. It's equal to 0.6585 times 10 power 3 Newton meter square per Coulomb square. So flux phi E you can write by multiplying 10 power 3, we can get 658.5 Newton meter square per Coulomb square. So this is the amount of the flux which is passing through that angle 40 degrees.